Well, good morning, everybody. So, yeah, how did I come to be working at Acorn? It's a very good question. So, trying to get the next slide. There we go. So, in 1983, I was working out here in Australia for a company called Barson Computers, who were the Acorn agent out here, Acorn and Sinclair, in fact, out here in Australia. And at that time, there were two new technical people who were hired at virtually the same time. I arrived a week after the other chap, Keith, and because the pile of broken Sinclairs was bigger than the pile of broken Atoms, he was told to go and work on that. So I got the Acorn workload, and he got the Sinclair workload, although we did share a lot. And at that time, we had System 4s as workstations, Atoms, and we were just starting to get a couple of BBCs and starting to sell them to schools as a big network system. With what we were planning to deliver, I think, was probably System 4 file servers. But of course, these sales were taking place all over Australia, so up the East Coast, so not just here in Melbourne. And what we were getting at the time from Acorn was very, very early code. So this was the 0.1 and some early DFSs. I wouldn't know the numbers on those. And we didn't even have NFS when I first joined at the beginning of '83. And there were lots of deliveries and people were relatively happy, but of course we were keeping up the pressure on Acorn to deliver, get their new code working. Whenever they had new Econet code, new NFS, new MOS, new basics, whatever, they would be posting it out to us. So we'd receive EPROMs in the post. And obviously we had a completely different ecology here. We had different printers. So none of the View printer drivers that we were getting from Cambridge were of any use. We didn't have things like the Olivetti inkjet or whatever. So one of the tasks that fell to me was to say, okay, if we're going to support these big school installations with their file servers, print servers, and all of that sort of stuff, and even individual uses where we had, you know, as you do in the UK, the machine on the trolley with the telly and the printer. We needed printer drivers, and I was doing these printer drivers, and it was a horrendous effort in that I was actually keeping source code and editing it with View and then piping it through into BASIC to then assemble the printer drivers. And I was getting some support from Acorn for doing this, but in general, it was an interesting time. And so that was really my first effort at some real assembler program for the 6502 and for the BBC. Obviously, there are a few basic programs along the way. And we finally got to the point, probably middle of 1983, where a sufficiently robust version of NFS had arrived. We were probably running with OS 1.0 or maybe 0.9 by then. But our big problem was that we didn't have big EEPROMs. We only had 2764s. And so we needed a way to deliver a machine with an up-to-date MOS and an up-to-date NFS, as well as BASIC. And the Beeb at the time only had the ability to either run the OS in the OS slot and one sideways ROM, either as a single sideways ROM 16K or as 4 4Ks. And you weren't able to run anything with more than one sideways ROM, whether they were anything other than single 16K images. So what I did was provide a hardware hack whereby we put the basic ROM in the OS slot and had 2 sideways ROMs split as each a pair of 2764s. And there was a little chip on the back of the board to do the extra decodes. And once this was sorted out, tested and decided that that was what we were going to do, I spent something like 3 weeks traveling up the East Coast, up into Queensland and Sydney and some in Melbourne, doing modifications to existing Beebs to deliver all of this code so that they could get on with their world and actually start doing network computing. So I had a suitcase full of soldering iron and pre-programmed EEPROMs and chips and wires and all God knows what. And so this was a pretty interesting introduction to doing technical support. And from then, during this time, we also had very, very good support from Acorn itself. We had a visit by John Cole, author of the BBC User Guide. He came out for almost a week, I think, and he was moved about, taken to various meetings and so on to show our customers, Barson's customers, that Acorn was in support. And it wasn't just some fly-by-night operation. We had the full support of Acorn, and as soon as anything was ready, we would be delivering it. So they shouldn't be worried about, paying extortionate prices that the Beeb seemed to be. And obviously we were getting our tech support by phone. So I'd be calling up Cambridge, and being young and stupid, I'd call Cambridge at 9 in the morning or 10 past. And if the phone was answered, they'd put me through and there would be nobody there, because at the time I didn't understand the tech culture, which is, oh, we might come in later, 10:30, 10 o'clock maybe. But I got the hang of that eventually. And some support even went over telex, which was pretty strange. I got to learn how to use the telex machine. And later, we even had one of the dial-up accounts with BT. There was a BT electronic mail system. Can't remember the name of it. Someone else will. And we had a 1200 baud modem, and we'd go online. We actually had to phone the UK, connect, and we could send emails. No one read them, of course, but we did send. And at this time, I'm I'm sure I was getting a reputation in Cambridge as a very annoying person who would ring early in the morning and ask all sorts of difficult questions. And at one point, the format for DFS floppies changed and a new disk formatter was required, and it was required very quickly because I think they'd shipped us software but no formatter. And so I said, well, look, just telex me the source of it and I'll compile, I'll assemble it here and it'll be done. And they said, no, we couldn't possibly do that. We couldn't possibly let you have the source. I said, all right, well, why don't we have a go at, you know, doing a dump of the binary and telex that? And they agreed to this and telexed the binary. And of course, it didn't work because there were transcription errors, probably at both ends. And eventually we had to agree to have a dumping type format with checksums. So you'd have a line of 16 bytes and then a checksum of some sort, so we could tell which lines were wrong, until finally, after about 2 or 3 goes, we got the working binary here in Australia, went off and formatted some disks. And just to prove the point, because I was young and annoying, I disassembled it and sent them back the source that they wouldn't have sent me in the first place. And I'm sure Hugo probably doesn't even remember that, but it is what it is. And after John Cole's visit had gone down very well, we asked Acorn again if someone else could come out. And this time they sent Mr. Joe Dunn. And Joe was the head of the systems group, who were Office Systems, who were the group that was doing the file server, the NFS and the DFS. So Joe was quite a technical guy. And Joe and I visited several schools and Sydney and Adelaide, and gave not short but quite intense little seminars and talks very similar to this that introduced the idea of using Econet, how to do your transmits and receives and all of that sort of stuff. So getting people into the idea that Econet delivered more than just the file server and the print server, that it actually delivered machine-to-machine communications, and that people could then go and write their own network applications. And having made these little seminars around, people here in Australia did actually start doing those sorts of things. There were systems popping up with network communications from one side of the office to another. There's a big system up in Rockhampton, up in Queensland, where they were using Beebs for newspaper typesetting. So they had one Beeb was connected to the typesetter and several scattered around the office, where reporters would write their stories, do some sort of in-text formatting, and then send it off to the machine across the network. The other thing about Joe was that he was, as I said, technical, and because we spent so much time together going around doing all these technical things, he got to know me. And later, probably November time, November '83, there was an offer from Acorn for me to come to Cambridge to work. And I was offered, and this will startle you how big it is, £8,750 a year to go and work at Acorn. And I said, yeah, I like that. That'll be an interesting thing for a 20-something to do. However, I had a wedding to go to in February. And I said, look, I'll have to come after the wedding. And they said, no, we've made the offer. You're coming now and we'll send you back for the wedding. So for some reason, they thought I was worth having. And so I came across in December 1983, and it was weird. It was very much a culture and thermal shock. So I was leaving Australia just as summer was coming on, getting to Cambridge just as winter was coming on. It was cold for someone who hadn't known cold like Cambridge cold. But fortunately, the Acorn silver building, which had only just been finished, was busy filling up. I'd even had trouble during some of the phone calls trying to get tech support with people saying, I can't hear you very well because they're drilling the foundations for the new building. So I knew it was in progress, but when I got there, it was all done. And so none of the struggle that was not living in the silver building, being forced into the waterworks, was for me. I got the lucky start. And I also got to start with a bunch of real nerds, real technical people, all my age, all very, very clever and interested and dedicated to their work. And there was a good separation at the Cambridge site. The nerds were all out in the silver building. Management, marketing, and all of that sort of stuff was in the front building. So it never seemed like there was too much of a battle between the two. We were left out the back to do what needed to be done. And people from marketing or sales would come out and say, right, well, you know, is this ready? No, of course it's not, and all that sort of stuff. We did have some management, obviously, but they were quite technical guys, and they were happy to just let people do what they wanted to do to a certain extent. And I'd taken I had a bug that I brought with me from Australia that I'd found while I was here, so that upon getting there, I could at least have something to discuss and something to do immediately. And for those who are interested, the bug was that when you did network reception, if the data was transmitted, then the data would arrive, as you would expect, in the receive buffer. And the receive pointers you got back from your OS call would be updated to tell you how much data you'd got. Except in the case of a broadcast, and in the case of a broadcast, the data turned up in the control block, not in the data buffer. So one of the first bugs that I got to fix in NFS was that bug. And later, that bug and the fixing of it would be very important because it allows printers to be found by name, by broadcasting the name of the printer. So I spent some time then getting familiar, finding out who did what. I got my development system, which was a Beeb 10 megabyte Winchester drive. There's a prototype one, but it was still a pretty good thing and pretty high tech. There weren't many, Acorn weren't selling yet because we were still in prototypes, but we had enough for development people. 6502 second processor, obviously, and a couple of Greenwiches. And for those who don't know, that's a battery-backed static RAM that has a pinout like an EEPROM, and it has extra terminals on one end which allow you to send the requisite write pulses. So you would have one of these and they were the same pin spacing as a normal EEPROM. They were a bit bigger around the side and they were something like 3 centimeters tall. So you couldn't have your keyboard in if you had one of these in because they were just too tall. And I'll just try, I think somewhere here I might have a picture. Okay, so I was only able to find pictures of smaller ones. So we were using the Greenwich as a replacement or as a quick development hack to get our code, assemble, and then blow it into the Greenwich, and then you could reset your machine and off you went. So although we did have EEPROMs and we were erasing and burning EEPROMs as necessary, for development, we were using effectively like a sideways RAM, which was pretty outrageous back in 1983, 1984. And I have no idea how much those things were, but I can imagine they were pretty pricey. But essential for development, really. The other thing that was a bit of a surprise for me and a culture shock was going for a pub lunch with all the people in development 5 days a week. It was interesting, and after a while we even got into a sort of habit of which pubs we'd go to and when. And it was all part of a very, very interesting and enjoyable and engaging nerd culture that was rampant at Acorn, which was all the people who were doing the technical work were all very, very similar in outlook and thoughts and all of that sort of stuff. So we all got on quite well, really. Right. The other thing that was a bit of a surprise to me was that Acorn really did use Econet in its day-to-day world. So there were System 4 and System 5 file servers. There were some printer servers. We had a quite big line printer, a proper belt printer, if memory serves me, for full width line printer listings. Eventually the hard disk file server turned up, but to be honest, most people who were in development had Winchester disk drives, so they weren't needing to use the file server all that much, and we were still using Econet, as in carrying 5-inch floppies from one place to another to share code. We also were starting to get on with printing. So we had a printer server initially, and later there's a printer spooler, and I'll talk about that at a later point. Brian Robertson was also working in sort of 84, 85 time with the bridge, which allows you to connect 2 networks together. Until then, there had been networks in the Silver building and in the front building at Fulbourn Road. However, they weren't connected together. So people up the front who were doing their document preparations or whatever were on one system, one network, and out the back we were on a different one. And having got the NFS, as in DNFS 1.2, finished and out the door with all its bug fixes and all its code space issues, we were then looking at a clean sheet for where we might go for improved network filing system for machines yet to come. And I'll just hark back there for a moment. One of the things was that from DNFS 1.0, the ROM was full. There was no spare bytes. So any bug fix that you had to present to your colleagues with, this is the bug fix, this is the number of extra bytes that it's going to take, and these are the places within the code that we're going to save those bytes. So you had to go and trawl through, always looking for where you might save a couple of bytes. And in fact, that always went on. Pretty much all 6502 code was space limited. And for those who've ever done any 6502 programming and been up against the space limits, you'll know that one of the things you have is a little table that sits by your development area that tells you how many times a piece of code has to exist before it's worth making it into a subroutine. So things like a 4 or 5 byte sequence can be subroutinized after it occurs about half a dozen times or so. So you'd look through your code looking for things that looked similar, work out whether you could permute the register use, make it into a subroutine, and save 1 or 2 bytes for your new piece of code. So getting back to ANFS, although it was started as a development project and hosted on the Beeb, it was really intended for the master. So the master development was taking place. Some people were working on the hardware in some level of secrecy, and others will speak to that later, I believe. We had a single wire-up prototype for the first version of the master, which was very interesting. So again, we just had one machine on which we could experiment. And technical guys from Office Systems and from AR&D who were looking into the MOS or the OS, and were doing things like the OS design per se and graphics drivers and such like. We all got together, especially over our lunch times, and worked somewhat informally on the design of the master software system. What we'd need to do, how we'd work with increased space and the increased facility that we wanted to provide. And I believe we also had more space, more ROM space in the MOS, because the MOS had gone from one 16K slot to the MOS plus a sideways part of the MOS where things could go if they weren't needed to be there all the time. And so the development of ANFS started on the Beeb, and certainly as I was getting going with it, I was only targeting it at the Beeb. So I was getting to the point where I had a usable release, and allowing that to be blown into EEPROM, and then I'd go around and try and convince people to take my dodgy code, put it on their machines and tell me how badly it ran. And eventually it was there. And the things that ANFS offered, the major things, were there's much more support for numbered networks. We had Econet bridges by then. We had a large bridged network within Acorn, mostly in the silver building, but we could actually get through to the front building. We had ANFS supported more buffering of open files. So anyone who has any experience of the early NFS protocol will know that although the block read and block write calls would indeed deliver blocks direct from the file server, the character read and write would actually involve a procedure call to the file server carrying that 1 byte backwards or forwards. And the reason the design was like that was because the file server design or the protocol design was intended for the atom and the system where RAM availability was incredibly small. So everything that you wanted to do had to be mapped almost directly to a file server call or a file server procedure call, if you like. However, with extra RAM available, ANFS was able to buffer open files to improve the speed of byte I/O. And many programs had pretty much assumed that they would be running from disk rather than being considered for network use. And so for the disk, where there was buffering and had been all along, the network was incredibly slow when it was just NFS. And I'm sure that that contributed to Econet's reputation as being slow. However, we did have buffering added to NFS. So we had buffers for open files, and some effort was spent over the various months and years to improve the reliability and make sure that buffering worked when programs did interesting things like working backwards through files byte by byte. So they do effectively a seek -2, get byte, seek -2, get byte, seek -2. And it took a while to get algorithms and buffering algorithms that would work and keep up with that sort of thing. And the other major development for ANFS was this use of named printers. So instead of having to remember what number your print server was, the broadcast protocol could send out a little 6-character name, and printer servers could reply to say that they were that printer. There was a default name of print, but it allowed us to have things like daisy wheel or daisy or dot matrix, whatever, all of those sorts of things. And much later, we would be giving names to all of the print servers around the networks so that you would know that your local print server was called Fred or Jim or whatever. But if you wanted to send it to someone else's office, you could ask them what their local printer name was and print over there for them. Right, and I'll do with these in the reverse order. So we had an in-house project called The Joint, which was for joining 2 network segments together. So Econet network segments. So it would still be one network with only 254 stations on it, and it wouldn't have a network number, but the joint would allow you to have a physically longer cable by dint of regenerating the signals. It didn't allow you to go particularly fast, but as an early attempt at being able to have a network that covered a large physical area, it was a possibility. And I know there were a couple around in Acorn in the Silver Building early on, but I don't believe it ever got made into a product, unfortunately. And it was overtaken by the Econet Bridge, which allows you to connect 2 network segments, give them different numbers, and carefully work out which packets need to be transmitted across the bridge. The bridge was developed by Brian Robertson, and he spent a long time working on that. It was a very simple piece of kit. When you looked at it, just looked like 2 Econet interfaces and a 6502 and some RAM. But the thing that took him the most time was designing, simulating, and testing the startup code that worked out what bridges, what networks were where. So it's effectively like, I think it's called spanning tree. So you know that your ports are networks 7 and 35, and that on the 7 side, you can also see 3 and 2, and on the 35 side, you can see 5 and 99, so that you know what networks packets need to be forwarded to. And the bridge became a good product. It was one of those ones where we spent a long time designing, debugging, testing, and then it went out. And I don't believe we ever had code revision for it, which is a good testament to Brian Robertson. And the other major thing that we did in-house, and I'll be honest, I don't even know if it was ever sold, was we had a printer spooler. So at the time when discs, as in Winchester discs, hard discs, were becoming more easily available, we had a contractor in, at the time, now Professor, I think, Derek McCauley, who wrote a printer spooler program in BASIC, and it ran on the 6502 and would accept your print jobs, spool them away to disk, and then print them out. So the printer busy message disappeared, and it was nice to know that if you wanted a quick listing, you could do it now, and then after some huge printout had gone, then yours would pop out later. So that spooling really improved our lives in the Silver Building, although it did take a while. I think it probably took about 4 months or something for it to be designed, developed, and tested, and so on. Right, so that's about that. What is it? So during development and debug of ANFS and other network stuff, we had some tools that were essential. So the first of those is the Netmon program, which, if you're familiar with Econet, you'll know is pretty much the Wireshark of the Econet world. It shows you all the packets going past. Initially, it was had to be ported across so that it ran on all our systems. It would run on system 3s, 4s, 5s. Don't think it ever ran on the Atom, but it certainly ran on the Beeb as well. And it was brilliant at helping. Certainly in my office, it ran continuously. It had its own hardware and a small black and white CRT monitor, probably about 10-inch or something. And it was on day and night. I think I only ever turned the monitor off. I don't think I ever turned the machine off, because it was essential for working out what was happening on your network, and especially when you were looking at dicking about with the network primitives, as I was. The second thing I had, which was very helpful, was I wrote a giant basic program, which I referred to as the relay. And it was effectively a file server, low performance. So it would receive your file server protocol commands and requests, print them up on the screen to show you what was going on, and then send them on to an actual file server. The actual file server would then reply. Those would be printed up on the screen and then retransmitted to the station. to your Beeb or your Atom or whatever, your master more likely. And as a debug aid, again, it was invaluable. Maybe it looks like it now shows you what you see with Wireshark, in that it does the protocol analysis. But the important thing was that you could see what the protocol was doing. You had an independent implementation, so you could use it to debug the file server just as easily as debug the station. And you could even use it to muck about with the protocol and experiment doing various things like changing one thing into another or whatever. And again, an invaluable for development is being able to see what you're doing while you're doing it. A lot harder nowadays with networking, but that is what it is. And the other thing, which was probably a bit more specific to ANFS development, was again a large basic program that peaked the internal RAM space of NFS, or anything else in fact, and showed it in a logging sort of way, so you could watch things like buffer usage while you were running test programs. So you could see things like as a file was opened, you'd see a buffer come into use. As data was read from the file, you'd see more and more buffers allocated until it reached its buffer limit. And then you'd see old buffers from the beginning of the file reused, and you could watch that circulation happening. Open multiple files, watch it interleave, and all of that sort of stuff. And again, being able to see those internals was very, very helpful. Nowadays, we have the likes of GDB and all of those sorts of programs, proper development systems with debug via JTAG or whatever. But back then, there was nothing really very much on the Beeb. There was no, we certainly didn't use serial output as debug, whereas nowadays possibly you would. And there were LEDs, but we weren't really into the mucking about with LEDs. We were just using our brains for doing our debug at the time. Right. So one of the things that came along much later was that Acorn took, or bought possibly, took possession of a program called the Broadcast Loader, which was a very, very ingenious idea that someone had had for helping schools out, which is the classic problem of wanting to load every single station with the same program at the beginning of a lesson. And the file server wasn't very, wasn't fast enough to be able to do this quickly. And so what the Broadcast Loader did was that it would see, it was a piece of code that ran in your machine, and it would see that an attempt was being made to load a particular file. And when a second attempt was made to load the same file, then early parts of the file would be broadcast in packets out to the whole network. So anyone else who was thinking about loading the same file didn't have to go to the file server, could pick up these broadcasts as they happened, and the loading was much, much quicker. What we got in-house was pretty much proof of concept, and although it worked on a good day, it wasn't as robust as was needed. And I spent several months, again, working with this, trying to improve the robustness. And again, it was one of those ones where those two debug things, the Netmon and the relay, were invaluable for getting it working better. Unfortunately, my memory of the broadcast later is a bit hazy other than that, probably blocked out, I would think, for my own good. The other thing that happened around this time is we started to get laser writers, so that's Apple laser writers, in as our printers at Acorn. And so there was some development of PostScript and PostScript header files to wrap jobs so that text jobs could be sent to PostScript laser writers and various bits and bobs could be done. So again, I was back where I'd started doing view and other printer driver support in the PostScript, in the preamble that was sent by the print spooler to various laser writers. And at that point, we had a big sprawling network. Acorn was over probably 2 or 3 sites by then. We're at Vision Park in Histon and the Techno Park, Chesterton, and Fulbourn Road. And so getting networks working and having non-technical or less technical people being able to print good quality documents, save their files away on the file server was very important. However, around this sort of time, we were discovering that the real world reliability of Econet was perhaps not as good as we were achieving at home at Acorn. And so there was a lot of support required by customer services to talk with schools and large installations, trying to find out why they were having reliability problems. And of course, for the technical development people, we were going, well, you know, in the classic way, it works for us, what's wrong with you? And in fact, I had to spend time with some of the people from customer services, and we visited several installations, the ones that were having real reliability problems. And installations are of questionable quality sometimes. So unfortunately, the installation of the network cable is, as you probably know, if you're into Econet, is relatively important. It needs good termination, as in wires soldered down correctly or crimped down correctly. And it needs good, reliable cable terminators, clocks. And unfortunately, in the real world, this was not being achieved. People installing the networks weren't as assiduous as they should have been towards quality and all of this sort of stuff. When Carl Sellers and I visited schools, we were expecting to find, you know, really nice layouts. You know, they paid lots of money for it, but we found them to be really dodgy. And it took us several days sometimes to sort out problems at sites. And so it was disappointing for me as a technical person to see that we, Acorn, hadn't been able to take a good quality product and get it delivered in a quality way to actual end users. And I think it's a good lesson to have learned, is that it's not just about making it work in the lab or on your test bench. You need to find a way to deploy it. And I look today at our networking, as in 10 and 100 base T, even gig, and the fact that it is really now just plug and play is incredible, absolutely incredible. So people have spent time working on connectors and protocols and all of that sort of stuff. It's really good. And I don't know whether with this knowledge that we have now, whether we could have done Econet in a different way, maybe found a different, more reliable connector or better cable. But we were where we were, and we did what we had to do to get it to work. So let's see what's next. Oh, the Acorn RISC machine. So as I said earlier, I worked for Office Systems through various reorganizations. And up the far end of the Silver Building, the far end from where I started work, was AR&D, Advanced Research and Development Department, where the likes of Roger and Steve worked, John Thackeray, and various other people, not all of whom I got to know very well. And there were various projects going on up there that we weren't always told all about. And the secret one was the secret Project A. And if you've ever been to the Cambridge Museum, you'll see there are some ARM documents, including the, including the secrecy document that we all had to sign to get involved. And that alarm was to remind me, if you've got your questions from anything I've said, now's the time to send them off to the moderator via chat, so he can wrangle them ready for me to answer later. So eventually I was indoctrinated into Project A. I wasn't early to the party there. Other people were working on it. I was still doing other things. And one of the things I was asked to do was to make some test code for Econet to see whether it was realistic that we could code the Econet primitives in ARM assembler as it was. And so I made my test programs and so on. And what I found was that at the time, there weren't quite enough FIQ registers to do the job that was needed. And so I gave some honest feedback and I said, we need one more FIQ register to be able to get Econet to work fast and reliably and actually be able to code it and get in quickly and do what has to be done. And Steve Ferber said to me, well, you can't really have one extra register because of the way the chip was laid out. You had to have two. So that's why the FIQ register set is the size it is, because initially it was going to be 2 registers smaller, but it needed 1 more register. And because of the hardware way they laid out the chip, it had to be 2. So fortunately, this all happened before the first silicon. And first silicon came back, and as everybody knows, it was all a raging success. I've got one in my phone now and I love it. And the other thing that I worked on with respect to the RISC machine was the module system and the loading of software from it. Unfortunately, my memory of those bits of technology are quite hazy now, but it is what I got on with doing. And I think that's probably about where I'm going to end for now. If you do have any questions, I'll do my best, but as I've said, my memory's quite poor of those times, whether it's to do with beer or mental health thing where you block out stuff, I'm not sure, but I'll do my best.
All right, awesome. Thanks very much, Brian, for the talk. It was really interesting. And I think when I was looking in and doing a bit of research around this, one of the things that surprised me is just how much influence there was from Australia and even New Zealand around the Acorn story. So it's really good to hear that firsthand from a countryman in the region. But I do have a number of questions for you, so hold on to your glass of water or beer or whatever it is, and here they come. So
sadly, it is just water today.
it's probably a good thing. But the first question was from Ian S, and he asks, on the subject of the relay or the joint, the two pieces of software you talked about, do you still have any of the development software, hardware, or documentation for those items? There was a general interest in.
Nope. Unfortunately, I've divested myself of pretty much all Acorn equipment that I've ever had. It's all gone to the Cambridge Museum over the years. I certainly don't have any software or any hidden things like that. And none of it's followed me here to Australia, where I'm not really choosing to be. I'm sort of trapped here by COVID and family circumstances, really.
Okay, no problem.
Sorry about that. Everything I've had, I've always passed on to the museum in the hopes that it will be understood. And obviously, if they have questions, I'm happy to answer.
Awesome. Okay, another question from John Brown, just asking what was the general feeling in Acorn about SJ Research making Econet kits, and was there a licensing deal involved?
I can't tell you whether there was licensing involved. I would expect probably not. From the Acorn technical perspective, I believe that we had no problem with SJ doing their products. Acorn was always, as far as I could tell, open to other people doing their projects and supporting the Acorn ecosystem, Econet, disks, software, whatever, because all of it brought value to the product. And certainly with SJ being just down the road from us, I'd certainly been there visiting, talking with them on occasion. It wasn't a regular thing, but certainly we knew one another, we knew what we were up to, and there was always good cordial relations between the two companies.
Okay, interesting. And it does seem that everyone was pretty friendly back in those days from this and the other talks that we had. So it's good to hear. But so next question was from also from John Brown. Actually, he asks, did you work on the X25 gateway or the terminal emulation to X25? And if so, was it VT100?
I can't remember which terminal it was. I would guess that it was probably 100. It would have been at least VT52. And yeah, I had some peripheral involvement. It was more wrangling the contractors who were doing it, not from a project management point of view, but from a technical support point of view, answering what questions they had, helping them out when they needed help, and deploying the kit at Acorn. We'd already had some, within the company, we'd already had some experience with X25 in that we had a JNT pad which was connected downstairs with the computer, the VAX. And so at one point there was an Econet port, as in a movement of code, and a port as in a physical interface that were applied to the VAX by, and the name will come to me later. So the VAX was put on the Econet, and so Econet could actually talk to the pad and do some stuff. There was a terminal program, I think, that ran on the master that may have been able to use the pad, but I'll be honest, my memory of those is much too vague. Sorry.
Yeah, I'm actually, my first job in networking was X25, and the only thing I remember is Aloha packets, and that's about it. It was quite a while ago. So I have another question. Sorry, go ahead.
Yeah, the JNT pad was interesting, and at one point we were working, as probably most people know, with Acorn Research in Palo Alto. And I went out there with Hugo for almost a month, I think. And one of the things we did in preparation for going was I connected a beeb to one of the ports on the pad down in the machine room in the Silver building. So when you made a suitable X25 call, the reset line would be released, the beeb would spring to life, and you could talk to it over the serial port and thereby do some stuff. I can't remember very much what it was able to do, but it may have been, it can't have just been email because they would have had email. But yeah, we had a bodged together facility for accessing a beeb remotely via the X25 JNT pad. That's not the Acorn X25 gateway. This is years before that.
Okay.
Okay, next question.
Yeah, no problem. So, another question from Jason, JBN Beeb. He asks, in the absence of distributed version control systems like Git, how did you manage changes to the code back in the 80s?
Well, code management was down, I guess, mostly to discipline, as in, you know, you would work on your version, make a copy of your source files when you were making a personal release. When releases went for ROMing, then floppies would be sent down to the drawing office. And the other great thing was that we had a line printer. And so when you made a milestone type release, there would be an assembly and a printing. And then there'd be a binding. So you had plastic covers that would go on a line printer listing. And you'd end up with something, you know, up to 10 centimeters thick, which you could then peruse at leisure to look for A, where your bug might be, and B, how you might save time. And then we would physically annotate the listing to show what we were planning to do when we were doing what little code review we did do. And so you'd have huge listings with felt pen on the outside of the spine with NFS 3.32 or whatever, or OS 1.0. And these were somewhat the Bible for our development, and those were our forks, our points in the ground of our version control. Nothing more than that, just down to programmer discipline, make copies on floppies, and be done with it.
Brian, wasn't the thing about claimheader.system that we used to have and chatting over the partition?
Oh, that was a much later time, surely.
Yeah.
We also had several inflatable balloon animals, which you had to have the correct one on your desk if you were going to make a modification to a particular file. So you had to have the pink flamingo on your desk. If you didn't, you weren't allowed to modify header.system.
Yeah, those, fortunately, the Econet and the Beeb, there was not much sharing of files. It's only when we got to doing ARM-based software that file sharing became important.
Yeah, that's right. Most of the time it was a one-man project, wasn't it? Everybody had their own little project they were working on, so you didn't have lots of contributors to the same code base.
Bliss. My code, my world.
I've got a funny story about a dodgy debugging macro that I'm always going to tell.
Well, that's for later, isn't it?
Yeah,
I think you've got it.
but you did have some involvement in it.
All right, Paul, off you go.
That naughty Mr. Swales wasted hours of your time by selling you a Duff macro, didn't he?
Yeah, so basically, for ARM code, we had macros that you could insert in your code at that would print things and all that sort of stuff, so you could get your terminal-based debug going and all of that sort of stuff. And they were, when I went to the shop to get them, it clearly said on the packaging, no side effects. So you knew that you could just insert the macros in your code and all that would happen would be some printing. And yeah, that's about it, I think. Except, of course, it turned out not to be entirely true.
And I discovered this because I came into the office to find Stuart Swales cowering under his desk, shouting, "No, no, not again." And this nice Mr. Cockburn standing over him saying, "Come out, I'll do the other arm." Due to a certain amount of corruption of Supervisor Register 14, I think, wasn't it?
I can't remember what register it was, but I know it was somewhat elusive to find and a bugger when it wasn't known.
Hey-ho.
Hey-ho, indeed. Hopefully, water under the bridge now. Any more questions there, Simon?
Yeah, there are just a couple more. One more sort of general question, if you like. How prevalent were the Beebs and Econet in general in Australia?
Well, that's difficult for me to judge because I left and came to live in Cambridge. I worked for Acorn for 12 years.
Did you take the only network with you?
When I left, we as in Barsons, probably had a dozen large, as in, 15, 20 machine installations in schools across Sydney, Melbourne and Adelaide. We had enthusiastic dealers who were well educated as to what they were selling. So they would be able to say, yeah, look, we can do this. It does all of these things. And if you don't believe us, come and have a look at this installation that is working. Talk to the teachers there, because teacher to teacher was the best way of selling. So we were shipping Beebs to schools and to a certain extent to individuals as fast as we could get Acorn to send them to us. But then in those early days in 1983, Beebs were a bit like hen's teeth. They were difficult to get, but the company had a good in with Acorn and Sinclair. I'm trying to remember the name of the guy who was in charge of external relations. Oh, it'll come to me later. But yeah, it was good. We got lots of kit, got it out there. Kids were doing it. But once I'd left, I was on a new trajectory. Australia was well behind me. So I have no idea how it went. I know it remains, Beebs are popular everywhere, it would seem, especially in English language countries.
Mm-hmm.
Plus the Netherlands, where they use English anyway.
But this leads us quite neatly into another question, actually, which is a question from Jason asking, did Barson, as in your company, did it continue after you left Australia for the UK and working from Acorn, or what happened to the original company?
Yeah, it went on for many, many years. Lawrence Hardwick came to live in Australia and worked for them for many years. They went on for at least another probably 8, maybe 10 years. I'm not sure what happened in the end.
Okay.
That's about all I know.
And the last one on this list, really, well, there was two things I probably should mention. One is that Steve mentioned that Telecom Gold was probably the name of the email service that you were talking about. That was one message I got, which is apparently famous because the Duke of Edinburgh's account was hacked on it. And I think I remember that event. And the last one is more of a comment, really, talking about the pronunciation of Econet and Econet, and how interchangeable were they, and which one would you consider to be the proper one? I noticed you were using them kind of interchangeably, just like I do.
Yeah, I probably prefer Econet, but yeah, they're interchangeable. I wouldn't say there was a correct and certainly not a wrong pronunciation.
It's not like these days where you have Acorn marketing chasing after you if you say it wrong.
Do they really?
No. Okay.
I would have thought the only people working in Acorn marketing are skeletons now.
Well, they're still making the occasional branded mobile phone apparently, but I don't think it's the same people. But anyway, I'm going to open this up just to general chat across the floor now. That's all the questions I had. But before we do that, thank you very much, Brian, for your time. Really greatly appreciate it. It was really interesting to hear your firsthand, and it's not often that we get to hear from non-English people, so to speak, to get a little bit of a different view of what was happening in the Acorn world outside the UK.
I do nominally still live in the UK. Like I said, I am stuck here because of COVID and family situation.
Okay. So you're just out there on an extended quarantine at the moment.
Yeah. I'm dying to get back to my house in Cambridge.
Yeah, come back, Brian. We miss you. As you know.
I think he's waiting till the pub's open.
I was about to say it's probably the pub lunches that are drawing him back.
Well, it will be. There's no pubs and no going out here under level 4, I can tell you.
So
no wrestlers.
No wrestlers. I have to make my own. It's shocking.
But we still have 5 minutes, I believe, on the schedule. So if anybody in the Zoom meeting wants to unmute and ask a question, then please go ahead. Always takes a little bit more bravery than the chat questions. Let's see.
So it's Chris Turner here. Hello.
G'day, Chris.
Hey, Chris.
And I just want to say hello to Brian, really, and say how great it is to see you in what appears to be rude health. And
I am indeed in rude health. I've been keeping indoors and away from Mr. COVID and his friend.
I have one question, one comment and one question.
Yep.
The comment is that, in my opinion, it's Econet.
Very good.
What it's worth. My question.
For what it's worth, I agree with that. Econet, long, always.
Yeah. And my question to you, which may cause a reminiscence on your part, is: have you learned to park your car properly yet?
No, of course not.
Would you like to explain, or shall I?
You should explain.
So, as we filled up the Silver building and had demolished the porter cabins, inevitably we very quickly ran out of car parking spaces, and various memos were sent around asking people to park properly. My office looked down over the car park at the back of the Silver building. And on days when Brian was in a bad mood, perhaps when somebody else had messed with his code or something, he used to take delight in parking his car semi-diagonally across at least 4 spaces, 6 on occasion when he could.
You can, if you're careful, you can actually not only score a 4, but if you put it 90 degrees, you can score a 6.
Yeah. This would cause those of us who were attempting to manage research and development in the Silver building to draw lots to see who was going to go and talk to him about it. That's enough from me. I'll speak later. Cheers, Brian.
Yes, Chris.
I had a question, Brian.
Oh.
Do you know where
yes.
the origin of the level 4 file server was? Did that come from any of your relay code in the first place? So is that where it started? Because that was all written in
Not as
BASIC as
I'm
well.
aware. There was, let's think, the original file server code ran on the system, and it was then ported to the BBC with a second processor, 6502 second processor. And then there was a port, I think that would have been level 3, which was the support for the Winchester disk. And my memory is that the formatting of the disk was different to Advis. Hugo, can you comment? Yeah. So it was just treated as a giant resource because file server disk storage was formatted with access control and passwords and all of that sort of stuff. So it needed to be different.
Even the
I don't
floppy
remember
file
much of-
server disks were different, weren't they? Right? The level
Yeah.
3 floppy file server disks were a different format because of having, well, for a start, file servers existed at the same time as DFS, which was absolutely incompatible. And yeah, basically they had a sensible directory structure implemented somehow that I think only Jez understood and Lawrence understood, and probably you did. I don't know.
Yes, because the directory was an extensible object, because it was hierarchical rather than DFS, which was not.
Indeed. I'll cover that later.
Very good.
I've got a quick question, if I may. It's about the you were saying about quality of installations in you know that people had done. I actually worked for a company that installed a lot of networks in schools, and the reliability was always great with them. The name of the company was Fluid Technics. I quite often ask if anyone either remembers them or has any stories about them or had any dealings with them.
Well, my comment would be that, of course, what we heard about back at Acorn was not the good installations, but the problem installations. So that's why you went under the radar, because you weren't causing any trouble. You were doing the right thing.
That's probably yeah. That's a good answer.
I can actually remember one of your team coming to visit our school to try and diagnose the network problem. And it wasn't a cable installation problem after a lot of diagnosis. And I don't know if the team found it or we found it afterwards, but it was one of the power connectors on one of the beebs, the spade terminals on the motherboard, had cracked and so was high resistance. And then that was randomly causing network corruption. That took a long time to find.
Wow. Yeah, those little spade terminals that went into a plated through hole. Yeah, I was never 100% certain that they were the right thing. I'm sure Chris Turner must have loved them.
I'll add a comment which addresses one of the earlier questions, if we're happy to spend the time, about
Absolutely.
backups and stuff like that. There was a time when, indeed, management sort of realised, oh my God, we ought to have better backups than just these listings that people had on their desks. And in particular, the drawing office invested in a big posh fire safe that they were very pleased with. And so we workers were invited to, well, we were given the opportunity to place our backups in the fire safe, courtesy of the drawing office, if we wanted to. And this would have been very useful. I mean, I took the view that the purpose of this backup is in case the office is burgled and all of the stuff on my desk was stolen, or in case of the office burning down. Essentially, it's a fire safe, right? So it was a backup to be used by me for recovering my state if a hardware disaster destroyed my storage. The drawing office took the exact opposite view, that it had to come with build instructions and documentation, just like making a release that they were going to put in a ROM. So basically, you know, we put stuff in and they said, we can't store this in the fire safe. Why is that then? Well, we don't know how to build it. Yeah, but you're not supposed to know how to build it. It's a backup for me to use if there's a physical disaster to the company, not for you. Oh, I don't know about that. Oh, we just gave up. It was a lost opportunity because of, you know, this idiotic pedantry. All I wanted was, you know, an envelope that said, for my use if the building burns down or my hard drive fails or is stolen. But no, it had to be made like a proper release that they could write down on their special big A0 bits of paper if they wanted to. So that was a wasted opportunity, but that was all we had in terms of backups and source control, you know. We would actually, you know, shove the sources such that they were, when they'd fit, on a number of floppies and take them home and put them under our bed every couple of months after we'd felt we'd done quite a lot of work. you know, it was that sort of thing. There was really no formal source control other than what Brian said, all the obvious common sense stuff, playing nice together if you're working on a project in common. And yeah, we took stuff home, put it under our beds for safekeeping. Next.
I remember checking the basic source code out of that drawing office fire safe in about 1984, and all of their efforts to try and make it so that it was a complete build release were completely thwarted, because the source code that was in there was written with an assembler called UASM that ran on a piece of hardware that nobody had anymore, called a System 3. So what you actually needed, of course, was to check in a copy of your hardware that you compiled it on as well, in order to comply with their draconian instructions. But of course, that was impossible. So
oh, you can't put hardware in the fire safe because hardware is prone to catching fire, right?
yeah.
Yeah, exactly. They tried to do what they tried to keep it in the control, but they didn't really know what they were doing. In that, yeah, they didn't also check in a particular version of the binary of an assembler that was used to build whatever you were trying to back up. Because if you were doing that, then you'd need to put in the source code of the binary of the assembler, and then also you'd need a copy of whatever it was you assembled the assembler with, which was probably the previous version, and so on recursively.
And a copy of the whole unknown universe.
Exactly, yes.
Yeah, but those were early days, and we were in those particular areas, we were all equally out of our depth to a certain extent. It was all new.
Yep, indeed. Indeed, but yeah, I mean, the thing is, the drawing officer's approach really was as if checking the drawings for the machining of a carburettor, right? Yep. Where you've also written down the spec of the block of aluminium you start with, and that's all there is to it. In other words, an inherently much simpler system, shall we say.
So, Acorn, was the Econet installed there actually, did that have a good enough performance for what Acorn needed at the time, or was it forever being slow and overloaded?
My memory is that because most people had local storage, it was really only used in the later days for printing, maybe a little bit of small files for file storage and so on. But yeah, it met our requirements. But then we were doing very, very different things to what a commercial organization might be doing with computers and a network, and certainly what schools were doing with computers and network.
Can I ask a second question?
Please.
One of the Alan McFarlane interviews is with Andy Hopper, who Herman Hauser was also interviewed. He said that Andy Hopper had quite a lot to do with the kind of theoretical side of the early Econet design. Did either or any of you have much involvement with Andy Hopper, or any stories about his involvement?
I can say that when I got there in late '83, Econet was a pretty much a well-known, well-understood design. It had come out of probably the likes of Andy Hopper and Carl Deller, I think, may have had some early hand in it. And the design of the physical layer protocols, the file server protocols, was all very computer science oriented, because the people that had been working on that had come from the computer lab, if my understanding is correct. So by the standards of the time for 6502 code, the code and the building and the running of the file server code itself was incredibly over the top. It ran its own, although it was written in 6502 assembler, it had effectively a procedure call stack and procedure entry and exit protocol code templates. So you would set up what you were going to do, you'd set your arguments up, it all went onto a giant internal software stack, and then you'd call the relevant module with its procedure arguments and its function code, and off it would go and do it. So it was very, very sophisticated in that respect. It wasn't just a big flat pile of assembler like BASIC and the OS and the disk and so on.
On that, I remember being at the computer alumni dinner 18 months ago, and Andy Hopper was talking about Econet and the origins of it. And I learned something, which was that I used Econet without knowing, because there were a group of 4 68,000 based computers at the computer lab that they used to teach the assembly language programming course on, and they were attached to each other by Econet. So these there wasn't just Beebs that were using it at the time.
That's because Mike Muller was building those things, right?
Yeah.
Mike Muller was responsible for building those 68,000s when he was doing whatever continuing education in the computer lab. And they were never ready in time for us. So my particular final year assembly language projects were very easy and very generously marked, because there was no hardware to run them on. Hurrah. Yeah, I was going to add also that the fact that Econet is CSMA CD with only a vague attempt at CA, if you know any of those things, carrier sends multiple access, as opposed to a token ring system or any of the other network architectures that were possible. I'm sure all of those designs came out of computer lab consulting, right? So yeah, the fact that it had an architecture in that sense of detecting when someone else transmits at the same time and both of you getting an interrupt PDQ, so you can stop and then wait a random time depending on your station number before trying again. And also that it senses if anyone is transmitting at the time before even considering starting, right? So in theory, there should be very few collisions. That sort of architecture and the proofs and test cases that it all worked definitely came out of the lab. Lots of lab people consulted to Acorn when they were making their early stuff. I mean, for example, the open file stuff, as in, put and get bytes in DFS, was written by Arthur Norman as a contractor, I believe. I won't comment on the quality of that code, given the constraints of the time, but there was all kinds of things where it was, oh, Arthur Norman wrote that. You want to, talk to him if possible. Easy to work out for yourself. But yeah, there was lots of lab influence there, which is why things were done properly.
So, Paul, I just wanted to check with you that when you referred to those 68K systems, that they were indeed on Econet and not Cambridge Fast Ring.
Well, I thought they were on the ring, but this was what Andy Hopper was saying at this particular talk that he was doing. So I thought, oh, I didn't know that.
Me neither.
I think it was both.
In fact, I'll be covering some of this evening, but yes, Mike Muller worked at Orbis and put some 68K systems together to complement the stuff that was going on in the lab. But as far as I don't recall much about an Econet to CFR gateway. If there was one, it passed me by. So
I agree. They were. Hi, Chris. By the way, they were certainly accessible. They were certainly accessible on the fast ring via whatever terminal concentrator thingy. Yeah. On the rare occasions they were working, and we were allowed to see them. So yeah, I mean, maybe they had an Econet between them for other experiments for other projects as well, because that's the sort of thing the lab would do, right? Put every interface you can think of on it so that different projects can use different bits.
Yeah, and maybe that helped enable those guys who are over in the lab, moonlighting as it were, putting together the things like the filing system. Yeah. Yeah, I was going to cover that again this evening, but yeah, and Andy had his research fellowship, research studentship and fellowship working on the Cambridge Fast Ring under David Wheeler and co. And they were very aware of the early Econet work by Bob Metcalf and over in the States, the Aloha network. And as you said, Hugo, a collision sense, multiple access, collision detect, and so on, which is kind of in a way a cheap and cheerful way of communicating, but of course it doesn't give you sort of granularity of control for multimedia and things like that, as we found out later. And the slotted ring chose to go off in a different direction. But Andy came to us and said, well, if you guys want to build a network, you really ought to do a version of a collision sense multiple access network, because that's the cheap and cheerful way, as it were, of getting a network up and running that will reach sort of cost point that you want. And we took that idea and the Motorola 6845 UART chip, framing chip, a sketch from Andy of what the line drivers and receivers might look like, which didn't really work that well. Lawrence Hardwick spent a long while playing with clocks and terminators and things and op amps to get the line drivers and receivers working and getting the magic resistor values right. And that the core of that design then got transferred in the Atom, in the systems, and then into the Beeb. And as Brian has said, by the time he came on the scene, well, and yourself, Hugo, that sort of basic of the line drivers, the receivers, the framing chip, the lowest levels of protocol, they were all pretty much set in stone and proven to work as well as they ever would.
Yeah, indeed. They were fully debugged by the time the very lowest parts were fully debugged. The 6854 ADLC, Advanced Data Link Controller, was there. And I guess Acorn must have been one of the biggest buyers of those chips.
Which is how come we got to know Robin Saxby. I'm blowing all my powder, or whatever the right expression is, for this evening's presentation, so I'm going to stop now.
Right, yeah.
But I think since we're coming to a natural stop, I mean, we have a break now for 1 hour before we go into Hugo's presentation at 1 o'clock. So just to wrap this up, Brian, again, thank you very much for your time, sir. It was an absolute pleasure to listen to you. I learned a few things. I hope everybody else did as well. And to the general Acorn team as well for chiming in and giving us some insight into